Okay, good day class. Okay, so yesterday we have learned how to find the definite integrals of an algebraic expression. So today we are going to see some laws, or we call it properties of definite integrals. So together we have 5. Okay, the first one, when you integrate fx with respect to x from a to a, means the lower and the upper limits are the same. Okay, so the answer will be 0. We can prove here. Alright, let's say integrate fx, you get integral capital Fx from a to a. So you sub in the upper limit, so fa, minus sub in the lower limit, also fa. So fa minus fa, 0. Alright, so it is very clear. Okay, the second property is you integrate kfx dx with, from a to b. So means that you integrate fx, but this function fx multiplied with the constant k. So we can just put the constant k outside. Alright, and the third one, so integrate fx dx from a to b, same as negative integrate fx dx from b to a. Means we reverse the limit. This is from a to b. This is from b to a. So their answers, the digit of their answers are the same, but with opposite sign. One positive, then another one negative. Okay? And the fourth one, you see, when we integrate fx from a to b plus integrate fx from b to c. So we can combine them, but with condition, both integrand must be the same. So this one from a to b, then continue b to c. So we can just combine them, and same as integrate fx dx from a direct to c. Okay, and the last one, fifth one. Okay, so the fifth one is, let's say if we integrate from a to b, the summation or difference of two functions, fx plus minus gx. Then this one we can split them. We can split them, become integrate fx from a to b plus minus integrate gx from a to b. Alright, so just these 5 laws. Okay, so we will see some examples. Okay, so you have to understand that this part you have actually learned in SPM. Alright, so I just go through one examples only lah. The rest actually no need lah. Okay, Alright, let's see the examples. Sure. Alright, so the example is like this. Okay, so the question, you are given integrate gx from 0 to 8, the answer is 7. What if gx is not important? We will apply the laws or the properties only. Okay, number first one, find integrate 0 from 0 to 8, 7 over 2 gx dx. Alright, so first it's clear that we are going to use the second law. Multiplied with the constant, so we can put the constant outside. Right, so next step. Multiplied with the constant 7 over 2, so we can put 7 over 2 outside. Alright, so when we put 7 over 2 outside, very simple. Just now given, right? This part is equals to 7. So just multiply 7, then your answer is 49 over 2. Alright, second part B. This one, integrate 0 to 8 for the function gx plus 2 dx plus integrate 3 gx dx. Alright, so you see that this part, okay, this part, of course, we are going to use the fifth properties. Alright, the fifth property, where we are going to split that. Whereas the second part here, we are going to use back the second one, the constant 3 we can put outside. Alright, so very simple. So this is a question. So first step, we split this one. Gx plus 2, we split it, become 2 integrals. Alright, this one, the 3 we put outside. Okay, now we can sub in the values. So integrate 0 to 8, gx is 7. This one also 3, 7. This one integrate 2, you can do it, right? Even though we don't know what is gx, that doesn't matter. But we can integrate 2, right? So integrate 2, you get 2x from 0 to 8. Alright, therefore the answer, so this is 21 plus 7, 28. This one sub in 8 inside and sub minus sub 0 inside. So you get 16. So 28 plus 16, 28 plus 16, yeah, 44. Okay? So this is how we apply the properties. Okay, so next, question C. All right, so I want to do as homework. Okay, please drop down. Okay, C you do as homework. Just follow something like this only. All right, and number 5. Okay, question 5. So this one actually quite simple. You see, the integrand all are gx, gx, gx. And let's look at the limits. This is from 0 to 2, then continue 2 to 5, then continue 5 to 8. All right, then of course we are going to apply this one, the fourth rules. Here, the fourth rules. Or we can combine them because the limit are continuous. All right, 0 to 2, 2 to 5, 5 to 8, continuous. So we can combine, become straight away 0 direct to 8. And the answer is 7. All right? Okay, so this is the example how we can apply these properties. All right, so next. So after we have learned the rules, okay, next we are going to see. Remember, last lesson we have discussed how to find the definite integral, but for some integrand that we can actually integrate quite directly. Or we can integrate directly by you apply the formula, or the worst one is partial fraction. Remember, we haven't discussed how to find definite integral where we need to use substitution and integration by parts, right? Okay, so today we are going to see this. Okay, let's go to one by one. So now we are going to see how to find the definite integration by substitution. All right, so when we use this method, the limits of the integration originally is values of x. Correct, right? Like this lower and upper limit 0 and 8 is actually the value for x, right? But when we're using substitution, we are going to transform the integrand into values of u, right? We change the variable become u. We transform the variable become u. Therefore, you have to allowing direct calculation of the required definite integral. Also means that the limits also we have to change to value of u. Originally is value of x. Then you have to do one more extra step, which is you have to transform the limit to become the values of u. We will discuss how to do it. Okay, so we are going to discuss two questions. Not two questions. We are going to go to exercise 3.7, questions 2, and we'll discuss one past year question on STPM 2020. All right, so you can check your textbook. Okay, so next, exercise 3.7, question 2. This one. Okay. So evaluate the following integral using suggested substitution. There are 6 questions here. So I'm going to discuss 3. I'm going to discuss B, C, and E. Substitution given to us. Please make one correction. For E, the substitution is not x equals cos theta. Or you cannot do it if you use this one. You have to change it to either x equals 1 minus 2 sine theta inside here, or you straight away use x equals sine theta. Both also can, but not cos theta. You do one correction here. All right, so we are going to see these 3 questions. Okay, so the first one, 2B. All right, 2B. Here. Okay, so the question said that integrate 8 over square root 3 plus 4x dx from 0 to 1. Okay, then you are given this substitution. They ask you to use substitution u square equals 3 plus 4x. Of course, because you see square root, right? So the first step, remember, for substitution, the first step is we differentiate left, right with respect to u and with respect to x. So differentiate this one is 2u du. Differentiate this part is 4 dx. All right. So next step, you see. Okay, next step. Okay, here first. So we sub in. Okay, so we sub in. All right. So okay, so this u square equals to 3 plus 4x, right? So you know that u is square root 3 plus 4x, from here. Therefore, this is u. Okay, and what is dx? I need 4 dx. 4 dx is 2u du ma. Alright, so 8 here can be written as 2 times 4, right? Yeah, 8 is 2 multiplied 4 dx. Alright, so the 2 I write here. So the 4 dx will be 2u du. Alright, so after substitute, it becomes like this. So the extra thing that we need to do here is, remember just now we said, this 0 and 1 is actually the value for x. Alright, is integrate this function from x equals 0 to x equals 1. It's a value for x. Now we transform into u. So these two limits also we have to transform into u. Okay, so how to do it? Very simple. You see the lower limit is x equals 0. So when x equals 0, so sub in here. So your u is square root 3. Yes, remember must do this step. Alright, then upper limit x equals 1. Alright, upper limit x equals 1. Then sub in. When x equals 1, sub in here. Alright, so u is square root 7. Okay, so remember. So the lower limit for u is square root 3. Upper limit for u is square root 7. Okay, please don't write wrongly. So remember the first one, lower you write lower. Upper you write upper. Okay, don't reverse the position. Okay, now can integrate already lah. So you see, u and u simplified. Oh, no more u, you see. So means that we are going to integrate 4 with respect to u. So integrate 4, you get 4u lah. So the limit, then as usual. As usual, sub in square root 7. So 4 square root 7 minus square root this side, minus this side. I factorize out 4 lah. So that look nicer. So again, if the question never mentioned, then we express the answer in exact form. So if involves cert, we write in the simplest form of cert. Okay, which is like this. Alright, okay. So the only new things is, yes, change the values of the limits. The rest, same, the steps are the same as what we have done before in indefinite integration. Alright. Okay, next, as I say, I'm going to discuss C. Alright. Question C. So you're asking to integrate x square root 4 minus x squared dx from 0 to 2. And they want you to use this substitution. Remember, we don't have to use the, even though it involves square root 4 minus x squared. But we actually don't need to do this one, do substitution. Actually, this one, you want to use formula can. Remember the formula f prime x fx power n? Yes, f prime x xx power n. Actually can use that formula to solve this one. Okay, this is your fx power n. So means your fx power negative half. Then f prime x is negative 2x ma. I have x here already, so I just need to add in negative 2 only. But that one, then we don't have to use substitution or no need to change limit lah. They don't want. Now they want you to use substitution. Okay, so this is the substitution given. So as usual, so differentiate left hand side 2u du, differentiate right hand side minus 2x dx. Okay, so next step. From here, I want to know what is my u lah. Okay. Yeah. Oh, okay, okay. Okay. Hold on, let me see. It's okay, never mind. So the next step actually like this. I want to change to u, right? So you see here, I need negative 2x dx. Then it becomes 2u du. Alright, so I have x dx. I have x dx, but I don't have the negative 2. I don't have the negative 2. So I can add in negative 2, right? So you get negative 2x dx, then you can transform to become 2u du lah. But I cannot suddenly add one value ma. Okay, so here I'm going to multiply with negative half. So balance, I just multiply 1 only. Alright? Okay, after we have done this, next we are going to change limits. Not yet. I haven't transformed to u yet. Yeah, I haven't transformed to u yet. Okay, I haven't transformed to u. So it's still x. It's still x. So this also still x. Okay, so the next step now, I'm going to transform into u. So it's like this. Okay, wait for a while. It become like this. All right. So from here, now we transform. Okay. So negative half. Okay, negative half is still negative half. So negative 2x dx, negative 2x dx is 2u du. All right. And square root 4 minus x squared is your u. All right. So again, already transform everything to u. So we have to change the limit lah. We have to change the limit. So as usual, your lower limit is x equals 0. So sub x equals 0. So your u is 2. No need plus minus because this one originally is positive square root. You see, it's positive square root. Whenever write anything means we refer to positive square root. So you don't have to say, oh, suppose write plus minus 2, right? No, we just take the positive 2. Okay, and upper limit when x equals 2. So sub in x equals 2. So 2 square 4. So 4 minus 4 is 0. All right. So don't confuse. This is lower limit. This is upper limit. So the u is here. 2 is here. All right. 0 is here. See carefully the upper and lower limit. Okay. All right. Now we see u and u simplified. 2 and 2 simplified. So left negative 1. So you just need to integrate negative 1 du. I think I write one more time. Okay. Integrate negative 1. So integrate negative 1, you get negative u from 2 to 0. Okay. So sub in 0, negative 0. Remember, even though 0, please write, because here you have minus. If you don't write this one, normally student will forget the minus. All right. Minus sub 2 inside, so negative 2. Therefore, your answer is positive 2. Minus positive lah. Okay. It's just like this. So just add one more step, or just do as usual the substitution way. Just add one step. You change the values of the limit. All right. Okay. Next, one more question. 2. Yeah, I'm going to discuss one trigo question or 2e. So you're asking to integrate cos theta square root 1 minus 2 sine theta d theta from 0 to pi over 6. All right, and the substitution given to you is x equals sine theta. They want you to use this substitution. All right, so as usual, differentiate the substitution. So this is 1 dx. Differentiate differentiate sine, you get cos theta d theta. Also, you must have cos theta d theta, then only can transform to get dx. Remember, original is theta. Now we want to transform into x. Okay. So now can transform already lah. So you see cos theta d theta is dx. So this one cos theta d theta. You have right. Cos theta d theta is dx. Alright, so inside sub in. So 1 minus 2 sine theta is x. So 1 minus 2x. Alright, 1 minus 2x. And square root. So square root I write as power half lah. Easier for us to integrate. Alright, so you already transformed this one into a form that now you can integrate already by the formula derived from the substitution later. So next step is, yes, we have to change the limits. This is the value for theta. Okay, variable is theta. So this is a value for theta. So we have to change to value of x. So from here. Okay, so when theta equals 0, lower limit first. So when theta equals 0, sub in. So sine 0 is 0. Okay, then next, when theta equals pi over 6. Alright, so x is sine pi over 6. Pi over 6 is 30 degree, right? So sine 30 degree is half. Okay, now you get the new lower and upper limit, 0 and half. So 0 and half. Alright, then after that, we use the formula derived from the substitution. Inside here is linear, right? So just index plus 1. So 3 over 2 over new index. Don't forget your a. The denominator have to multiply a also, or divide a, you see. So your a is negative 2. Okay, then limit 0 to half. Okay, so we simplify first lah. This 2 can simplify. So left 1 over 3. 1 over 3, negative 1 over 3. Oh, I didn't put up, I just put it here. Then sub in half. Sub in half here. Okay, minus. So denominator negative 3, sub in 0. Alright, so this one, 2 and 2 simplified. So left 1. So 1 minus 1? 0. Yes, 0. Please write. Okay, what else here? Minus, minus. Is it minus, minus? Become plus. Alright, so this one 1. 1 to the power of 3 over 2, still 1. Alright, therefore your answer is 1/3. Alright, so after discuss 3 questions, so I think you have no problem lah. Or just refresh back the method of integration by substitution. Only one step we add, where you are going to find the new lower and upper limit. Okay? So next, we are going to discuss one past year question. Remember, one past year question, which is STPN 2000. Okay? You have the past year question, right? But I still show you lah. Okay, STPN 2000. Question 3. Okay, here. Okay, question 3. This one. This year, they give you substitution. Lucky lah. Using the substitution u equals ln x. Use this substitution. Show that integrate this integrand from 1 to e is equals to 1 over 3 ln 8 over 5. Answer given to you. You just need to show until you get this answer. 7 marks. Alright? Let's see. So if 7 marks means the step quite long, quite many steps. Alright. Okay. Start with this. Okay. So we are going to integrate this one. Integrate this integrand from 1 to e dx. Alright. And the substitution given to us is u equals ln x. Before this, I find the new limit first lah. I find the new limit first. So lower limit when x equals 1, this value for x. When x equals 1, sub in here. So ln 1 is 0. So u equals 0. Okay. Then when upper limit when x equals e, so sub e here. So ln e. So ln e is 1, right? Okay. Therefore, your new limit is 0, 1. Alright. Now we sub in. Okay, 1. Hold on, one more step. Differentiate this one. Yeah, one more step. Differentiate this one. So, left hand side du. Right hand side differentiate ln x. 1x dx. 1 over x dx. Okay, so you have, right? You see, you have 1 over x dx. Here. 1 over x dx. So, 1 over x dx is your du. Yeah, you just transform it. Alright, what else? This one, ln x is u ma. So it's 1 over u plus 1. So you see, this is ln x, the whole thing ln x, then plus 1. It's not ln x plus 1. Don't confuse, you see. If they want ln x plus 1, they definitely will put bracket like this. Okay, if they don't put bracket means just ln x, the whole ln x plus 1. This one, the whole ln x plus 4. Alright. So ln x is u ma, so become u plus 1, u plus 4. So now we have complete transform. Alright, so this part using substitution. This part using from x transform to u, we are using substitution. Okay, after we have transformed, so when you see a new integrand like this, so immediately you have to think, okay, what method I want to use? I think you should no problem, right? Partial fraction. Yes, you need to do partial fraction. So I actually have done here, the blue color one, you see? Here, I do it here. Alright, so 1 over u plus 1, u plus 4 is a over u plus 1 plus b over u plus 4. It should be no problem for you, this step. So a multiplied u plus 4, b multiplied u plus 1 equals to 1. So we sub in u equals -1, sub in here. So -1 plus 1, so b disappeared. Okay, u -1 plus 4, 3a. 3a equals 1, a equals 1/3. Alright, then sub u equals -4 to eliminate this. Sub u equals -4 to eliminate this. So -4 plus 1, -3. So -3b equals 1, b equals -1/3. A is positive 1/3, b is negative 1/3. Okay? So after I calculate this one, I straight away right here. It becomes a is 1/3 u plus 1. B is negative 1/3 u plus 4. Okay? Now can integrate already, right? Alright. Here. Because both also have coefficient 1/3. Both also have coefficient 1/3. I factorize out to make our calculation easier. Alright? So factorize out 1/3. So this one integrate 1 over u plus 1, ln u plus 1. Minus integrate 1 over u plus 4, u plus 4. By right, we have to multiply 1 over a, remember? 1 over a, 1 over a. But now your a is 1, so we just omit it. Alright, then 0, 1. Okay, next step, sub in your upper lower limit. Sub in 1 first. So 1 plus 1, ln 2. 1 plus 4, ln 5. Minus, sub in 0. So when you sub in 0, ln 1, sub in 0, ln 4. Okay? So here we know that ln 1 is 0, right? Okay, so left 1/3, ln 2 minus ln 5 plus, or minus plus ln 4. Then we combine them, remember? Ln can combine become 1 ln. See? So ln 2 minus ln 5. So means ln 2 over 5. Plus ln 4. Plus means multiply. Therefore, the last answer, 1/3 ln 8 over 5. Which is same as what the question want you to show. Here. See? Same. Alright? So this is STPM 2020. Okay, so from here you know that when you want to do definite integration by using substitution, the step actually same as what we have done, just extra one. Calculate the new limits, the new upper lower limits only. Okay, fine. So now we will see how we are going to do definite integration by using integration by parts. Integration by parts. Alright, still remember the formula for integration by parts. Integrate uv prime equals to uv minus integrate vu prime. Okay, same step. So again, just that now we add in the limits. Alright, so when you look at the notes, okay, so we refer back to your notes. Okay, can see, see, number 5. So for definite integration by parts, it is important to remember that the terms uv on the right hand side of the formula, this one, the terms uv here, has already been integrated. As I told you before, right? Every time we just copy because it's done, alright? And so should be written in the square brackets with the limits indicate like this. So when we, this one is for indefinite integration. So when it comes to definite integration, the only thing different is we add in the limit AB. Because this one already done, already integrate. So we just straight away put limit AB and limit AB here. Okay, so just remember this step. Okay, so we are going to discuss some question in your exercise 3.7. Okay, question 1, HI, and question 4. Then 2 past year question that involve this integration by parts. 2019 and 2019 repeat paper. Okay, so let's look at your textbook. Question 1, H and I, right? Here. Question 1, I'm going to discuss H and I. So of course, J and K, you have to do yourself. Alright, H and I, and later, question 4 here. Question 4 later. When we want to do it, then only we see. Okay, exercise. So question 1H. Integrate x squared e 4x dx from 0 to 1. So as we say always, right, when you see multiplication of two functions, normally will be integration by parts. Alright, so if you want to do integration by parts, we have to decide u and v prime, remember? So of course, first we find ln. No ln, we find function of x. So this is u. So e4x will be your v prime. Okay, so differentiate u. So u prime is 2x. To find V, you integrate E4x. So integrate E4x, you get back your E4x over your A. Alright, then next, sub everything into the formula. So the formula is UV. UV, this one multiply this one, like this. As we say, this one already integrate, so straight away put the limit 0, 1. Okay, then minus, integrate V u prime, vu prime. So vu prime, this one and this one, this one and this one. So I write 2x first. Okay, dx from 0 to 1. Okay, alright, so you see next step. This one, as we say, already done, right? So we can sub in the limit already. So I sub in 1. So 1, so E4, 4. So it's 1 over 4 e power 4. This is 1 ma. Sub in 0 because multiply x. When x 0, so everything 0. Okay, so minus, okay, here, 2 can be simplified. So half, right? So I take out the half. I take out the half. So I'm going to integrate x E4x. Half I put out already. This half I put outside. Easier ma. So means that now I need to integrate x E4x. So you see, you have to do another time of integration by parts. Okay, now I choose u. My u is x, so v prime is E4x. So differentiate, you get 1. Integrate, same like just now, like this one, you get E4x over 4, or you write as 1 over 4 E4x. Okay, then sub into the integration by parts formula again, uv. So uv, so like this. Alright, so as we say, this is already integrate, so just put in the limit, minus integrate u prime, vu prime. U prime is 1 ma, so just integrate this one. Yes, so be very careful. Do one step by one step carefully. Alright, so next step. This one no problem, already done, just copy. This one, negative half. So remember, negative half. Negative half. So multiply negative half inside here. So sub in 1. Sub in 1. So 1 over 4 e power 4. Okay, sub in 0 because here got x, so multiply 0, whole thing 0. Okay, then this one, I take out the negative 1 over 4. I put negative 1 over 4 outside. So negative 1 over 2 multiply negative 1 over 4, positive 1 over 8. So integrate e power 4x, you get another e power 4x over 4. Alright, limit 1, 0. Slowly. You really have to do one step by one step slowly. Okay, next. So this one done, just copy. This one multiply in, like this. Alright, this one 1 over 8. Now sub in the limit. So sub in 1, so 1 over 4, e power 4. Sub in 0, not 0. Sub in 0, e power 0 is 1. So 1 left, 1 over 4. Okay, so next step, you just simplify them. So you see you have e power 4 here, e power 4 here, e power 4 here. So 1 over 4 minus 1 over 8 plus 1 over 32. Alright, so you suppose get 5 over 32 e power 5. Alright, and the constant is 1 over 4 multiplied 1 over 8, 1 over 8 multiplied 1 over 4 is negative 1 over 32. So I factorize out 1 over 32, so you get this thing. Okay? So definite integration by parts, the step longer, especially involve integration by parts twice. Then you have to do very careful, step by step. Don't rush, because once you rush, you will make careless mistake. Okay? Don't worry, we will discuss more examples. Okay, so let's see the next example. The next example will be I. Right? I discussed one trivial one. Alright, I. Okay. So I, you're asking to... Oh, okay, hold on. Yeah, like this. Okay, so you're asking to integrate x squared sine x dx, all right, from 0 to pi. So choose your u and v prime. So of course lah, this one will be something simpler after you differentiate, right? So I choose x squared as u, so sine x will be a v prime. So differentiate this one, u prime is 2x. So to get v, integrate sine, so you get negative cos. All right, so next step, apply into the partial integration by parts formula. So here uv, so uv, so I write it in the proper way, negative x squared cos x. Okay, straight away can put in the limit already. Minus integrate vu prime, vu prime, so minus 2x cos x. I write it in the proper way first. Okay, so next step. Okay, next step, this one I sub in pi. Cos pi is negative 1. Okay, x is pi. So negative pi square, negative 1. Okay? Cos pi, cos 180 negative 1. Okay, sub in 0. Cos 0 is 1, but multiply x when x 0, so everything 0. Okay, so and then next, because I put up negative 2 outside remember the properties. Okay, the properties of the definite integration that we learned at the beginning of this lesson. So negative 2 can put outside, so become plus 2. So means that I'm going to integrate x cos x. Negative 2 already put outside. So again, x cos x, we have to use another time of integration by parts. So here, so my u will be x, so v prime is cos x, so u prime is 1. V is integrate cos x, you get sine x. Alright, next step. So simplify this one is positive pi square plus 2 outside. Okay, 2 still outside, so I still remain, I solve everything inside here first. Okay, so can sub in 0 and pi here, right? Okay, sub in pi, sine 180, sine 180, 0. So 0. Okay, minus, sub in lower limit, x 0, so also 0. Okay, so this part actually becomes 0. Okay, minus, minus, this is uv, this is uv, minus vu prime. So vu prime, so means integrate sine x only. Therefore, integrate sine x, you get negative cos x, 0 to pi. Alright, so next step. Pi square still remain, 2 still remain. This one is 0. Hold on, let me see. Yeah, minus, yeah, correct. Minus, positive, okay, negative, become positive already, then sub in pi. So cos 180 is negative 1. Okay, this is cos 180, this is cos 180. Cos pi, negative 1. Minus, sub in 0, cos 0 is 1. Okay, is cos 180 is negative 1, then minus cos 0 is 1. This is cos 0. Okay, so the final answer, pi squared, minus 1 is minus 2. Minus 2 times 2, minus 4. Okay. So I discussed both questions, also need to do integration by parts twice. Alright? Not difficult right? But just have to be very careful. Okay. So for question 4, I actually want you to do as homework. Question 4. Hold on, I put back this one first. So let's look at question 4. Alright, you can see here. So first part, you're asking to show this one. Alright, so means that you have to do integration by part one time lah. Show that you get this answer. Okay, B, find the exact value of this. Alright, so actually they want you to do this one first. Then this one, you have to do integration by parts also. But you have to do 2 times. Okay, it's something that we have, what we have done here. Remember just now the question H? Remember, we do 2 times of integration by parts, right? So this one, they want you to do one first. Then when you do this one, after you apply the first integration by parts, you see that the integrate VU prime, that part will be same as this. So you just write answer only later. Okay? So I want you to do question 4. Just that this question, they split into 2 parts for you, so that will be easier for you. Alright? You do have to do quite long things like what we have discussed just now, H. Alright, so remember, question 4 will be your homework. So next, we are going to see the past year question. Alright, so just now we say that we are going to discuss STPM 2019. And 2019 repeat paper. So we will check 2019 first. Okay, this one. Okay, this is the question. Show that ln 16 minus x squared dx same as this. So when you see things like this, so you actually know already. They want you to use integration by parts. You see that uv minus integrate vu prime. Right? So you know that actually this part, they want you to apply integration by part. 2 marks only. Okay? First time. Alright? And hence, evaluate the definite integral. This is indefinite, no limit. Then this is definite. Alright? This one 6 marks. Okay? Alright, let's see the answer. Yeah, here. Okay, so I think you still remember how we integrate ln. Remember last time I said we cannot direct integrate ln. But if we insist want to integrate ln, we only can use integration by parts. And integration by parts needs 2 functions, right? Need 2 functions, u and v prime. So here only 1. So remember last time when we do, what we do? Yes, we multiply 1. We multiply 1 to it, because anything multiply 1 still remain the same answer. Okay? So now we have 2 functions already. First function is 1. Second function is ln 16 minus x. Okay? So of course, to decide which one is u and which one is v prime, so definitely u is this one. U cannot be 1. If constant after you differentiate becomes 0, so cannot continue already. Right? So no choice. This is your u. Then your v prime is 1. Okay, so differentiate u prime, still remember, differentiate ln fx, this is ln fx, so differentiate ln fx is 1 over fx, and multiply with f prime x, differentiate inside here, so negative 2x. This one you have to do a bit revision about differentiation. And v prime is 1, so to get back my v, I have to integrate 1, so integrate 1, you get x. Alright, now you apply into the integration by parts formula. Alright, so uv, so I write x in front now, easier, nicer. Minus integrate vu prime, this one multiply this one. So minus 2x over this one, multiply x dx. Alright, sub directly into the formula. Then next step, we write it in the proper way and as what the question wants us to show. Minus minus become plus. So 2 put outside. X minus, multiply x is x squared. This is what the question wants us to show, right? So 2 marks only in this question, you see. So I believe you will get 1 mark when you show all these 4. 1 mark here. And 1 mark for you to sub everything into the formula, the by parts formula, and write as what the question wants. 1 mark. Just like I said, this part 2 marks only. Okay, next, the important one. Okay? They want you to find this definite integration. Okay, so very simple. First step, just apply. You have done here. So just put in only. So uv, add in the limit, plus 2, integrate this thing from 0 to 3. The 2 just copy. Alright, so remember this one? I straight away write this is improper fraction. See? Improper fraction. Okay, so actually you need to do long division. This one cannot split. Remember, don't split as x squared over 16 then minus x squared over x squared. Cannot. Don't do that. Okay, you cannot split. So improper fraction, we do long division. Okay, I actually have done the long division here. See? Can see, okay. I actually have done the long division here. Okay, x squared divided by 16 minus x squared. 16 minus x squared, I write as negative x squared plus 16. Easier for you to see. So I have to multiply negative 1. Negative 1 multiply negative x squared, positive x squared. Negative 1 multiply 16, negative 16. Alright, so x squared minus x squared no more. This is 0. So 0 minus negative 16, positive 16. Alright, therefore you are going to write this part as minus 1, here, minus 1 plus 16 remainder over the divisor. I write back into 16 minus x squared formula. Can. So I think you will get 1 mark here. Maybe 2 marks. 1 mark for, because just now actually this part give you 6 marks, right? Also I believe when you do long division, this one you get 1 mark. Then you apply everything into the by parts formula, another 1 mark. So it means that this line already give you 2 marks. Okay, alright, next. So this one no problem lah. How to solve this? Remember, you take out your formula list. Take out the formula list that I ask you to copy down. So you check one by one. What you think you want to do it? So I look at this quadratic denominator. Can factorize or not? Actually, you cannot apply any other formula. The f prime x all cannot. Because if you involve f prime x, you must have negative 2x. I have no x here. We cannot add x, remember. Okay, but 16 minus x squared can factorize or not? Can, right? So actually next step is partial fraction. Alright? 16 over 16 minus x squared. So I do it here. See? 16 minus x squared is x plus 4. 4 plus x, 4 minus x. So two partial fractions, a and b. So a multiplied 4 minus x, b multiplied 4 plus x equals 16. So you see, actually in STPM question also, they like to ask partial fraction. So I sub x equals 4. To eliminate the a, so when x equals 4, 8b. So 8b equals 16, b equals 2. Alright, same. I sub x equals negative 4 to eliminate this one. When x equals negative 4, I will eliminate b. But 4 minus negative 4, then also 8, right? So 8a equals 16. So a also 2. So a is 2, b also 2. Alright, then I write in this one. So minus 1, 16 over 16 minus x squared is 2 over 4 plus x, 2 over 4 minus x. Alright, this is this part. Okay, whereas here we sub in the limit. Sub in 3. So 3, 9. 16 minus 9, 7. So 3 ln 7 minus sub in 0. So when multiply 0, everything 0 lah. Okay, the first part UV, you can sub in the limit and calculate already. The second part, I rewrite in partial fraction form. Okay, next step. Now I go and integrate lah. This one just 3 ln minus 7, just copy, plus 2, 2 here. Okay, so integrate minus 1 is negative x. Integrate, this one is 2 is coefficient, just copy. Integrate 4 plus x is ln 4 plus x. Suppose over 1, over a is positive 1, so can forget it. Alright, and this one also 2 here. So integrate ln 4 minus, integrate 1 over 4 minus x, you have ln 4 minus x. Remember a, so now your a is negative 1. So this one become actually over negative 1. Over negative 1. Alright, so I just change to minus lah, and the limit. Okay, now sub in slowly. This one just copy. Sub in 3 first. So minus 3, 2 ln 7 minus 2 ln 1. Ln 1 is 0. Okay, minus bracket, sub in 0. So this one 0. When this one is 0, so it's 2 ln 4. When this is 0, this one also 2 ln 4. Okay, so you see 2 ln 4 minus 2 ln 4, this one no more. Alright, so what is left? So left 3 ln 7, this one here, 2 times 2, 4 ln 7. So 3 ln 7 plus 4 ln 7, 7 ln 7, and this one minus 6. Yes, express your answer in exact form. Don't want decimal, that's why you cannot use your calculator. Okay, I know that your calculator can help you to calculate this thing. I know that your calculator can help you to calculate this one with the limits. But if the question don't want decimal, so you have to show all these steps. Okay? So don't depend on the calculator. Alright? Okay, so this is STPM 2019. Alright? Okay, last question. 2019 repeat paper. Yes, this one. This one. Can I? Remember, one of the quiz, I asked you to do this one without the limit. One of the quiz. So if we have done that one, then you should know what to do actually. Alright, but never mind, we go through again. So the question is, if tangent y equals 2x squared, show that dy dx equals this one. Alright, 2 marks only, so not too long step. There will be formula that you can apply. Alright, then hence means you must use whatever you have done here. Evaluate this definite integration. Okay, yeah, this part 6 marks. Alright, okay, let's see how the answers look like. Okay. Alright, can see can see the whole paper. Okay, good. Alright, so they give you this one, right? They give you this one. Tangent y equals 2x squared. Alright, so the easier way is we write it into arctangent form. If tangent y equals 2x squared, then y equals arctangent 2x squared. Remember in the exam formula list, in the exam, the formula list given you this one, right? Because next step, we are going to differentiate them. Remember, the formula list give you this one. Differentiate arctangent x is 1 over 1 plus x squared. Alright, but this one is x, but here is not x. So here is fx. So same, if integrate arctangent fx, so it's 1 over 1 plus fx squared. So x become fx. But because this is fx, right? Remember, all the differentiation the same, you have to multiply with f prime x. This is given in the formula list. This is not, but you apply the concept of for differentiation composite function. Where I always have to multiply f prime x one. Alright? So we are going to apply this concept. Therefore, the next step. So dy dx, differentiate arctangent 2x squared is 1 over 1 plus fx squared. So 1 over 1 plus your fx squared. Your fx is 2x squared. 2x squared and squared. Then multiply f prime x. Differentiate 2x squared. So it's 4x. Okay. Therefore, you show that your dy dx is 4x over 1 plus 2 squared is 4. So 4x power 4. So the question want you to show this one, remember? Show this. 2 marks only. Alright, so I think 1 mark will be given when you apply this. Apply the formula for 1 over 1 plus x squared and multiply this. So when you get this thing and write in the form that the question asked for, you get 2 marks. Alright, so 2 marks, you don't have to do the, the long method, the long way to prove this formula. The long way to prove this formula, no need. 2 marks only, so just apply formula. Okay? So next step, hence. Hence. Okay? Find this definite integration. Integrate x arctangent 2x squared dx from 0 to 1 over square root 2. So when you see multiply of two functions, right? Multiplication of two functions. So definitely integration by parts. All right? Integration by parts. Okay, remember we have to choose u. So our standard method is, remember to choose which one is u. I told you, right? Find ln first. No ln, then we find fx. All right? If no fx, then only we find exponential function. Alright, if really no exponential function, then only others. So if we follow these rules, so you will choose x as your u, right? Definitely you will say, oh, then I choose x as our u lah. Okay, then v prime is arctangent. So you see, if you choose u at x as your u, then fine, u prime is 1. Yeah, simpler. But if v prime is arctangent, can you integrate arctangent? Because to get back your view, if v prime is arctangent 2x squared, when you want to get back your v, you have to integrate arctangent 2x squared. Have you ever learned how to integrate arctangent? No, right? You never integrate arctangent. But you can differentiate arctangent. See that? You can differentiate arctangent. So therefore, this question is out of the norm. It's out of the norm. We don't follow this norm. But yet, you see, we follow what condition? We follow what condition? We follow the condition. U must be something, a function that you can differentiate. And v prime must be a function that you can integrate. Remember, this is the main concept. U is a function that you can differentiate. V prime must be something you can integrate. Okay, so you cannot choose this one as V prime because you cannot integrate this. So you have to do this one because I can differentiate this one, and I also can integrate this one. All right, so be very careful. So remember, this is just the norm for us to make a simple reference only. Okay, every time we go back to the concept. And what is the concept? The concept is u must be a function that can be differentiated, and at the same time, v prime must be a function that you can integrate. All right? Okay, so very clear. We only can choose x as our v prime. Then u is arctangent to x squared. All right? So v prime, differentiate this one. This is why they ask you to show this one lah. So just copy only. Differentiate this one, you get this. Just copy only. And v is x, so v prime is x, so to get back v, I need to integrate x. So I get x squared over 2. Alright, so after you have done all this, next step, sub into the by parts formula. Alright, sub into the by parts formula. So uv, so uv. So I write v first, nicer or easier to see. Then straight away put the limit here. Minus vu prime. Alright, so this is your u prime, this is your v dx with the limit. Alright, sub everything into the formula. Okay, next step. This one later, next step. So this one can settle already. We can sub in the limit. So sub in 1 over square root 2 into here. So it's like this. Sub in 1 over square root 2 minus sub in 0. Sub in 0 very simple because multiply x. When x 0, everything becomes 0. Okay? And to simplify this one, I do one part by one part. To simplify this one, okay, 1 over square root 2 square is 2 lah. So 1 over 2 and over 2, 1 over 4. Alright, this one also. Okay, square root 2 square is 1 over 2. 2 times 1 over 2 is 1. Tangent 1 is pi over 4. Tangent 45 degree is 1, right? 45 degrees is pi over 4. Okay, so this part, the pink colors bracket one is 1 over 4, pi over 4. All this can do. I finish first. Alright, then we go to the integration part. I go to the integration part. I simplify it. Okay, 2 and 4 can be simplified. Alright, so left, so 2x squared, 2x cubed. Alright, so 1 plus 4x4. Then again, you take out your formula list, then you check what formula we can apply. Actually, one very simple thing is, if you see denominator power 4 and numerator is 1 degree less than it, all right, so you know you can use the formula f prime x over fx. So if this is your fx, or if this the denominator is your fx, so you differentiate. So your f prime x is differentiate 1, 0 lah. Differentiate this one, index in front 16, index minus 1. So your f prime x suppose is 16 x squared. Alright, so next step. Okay, so suppose just now from here I get 2x cubed only, but if you want to use the form f prime x over fx, your f prime x suppose 16x cubed, but I only have 2x cubed. So how am I going to get my 16? Yes, I multiply 8. Number can, remember only can multiply number, cannot multiply variable. So if I multiply 8 here, I have 16. Again, cannot suddenly sub in 8, right? Yes, I put 1 away outside. Okay. So now this is in the form f prime x over fx. Alright, and to differentiate f prime x over fx, the formula is ln fx. The formula is ln fx. This one just now we simplified, we discussed already. This one. Okay, this one we discussed already. So 1 over 8 put outside. Okay, so integrate f prime x over fx is ln fx. Then limit. Okay, next step, just sub in only lah. Alright, so this is 1 over 16 pi minus 1 over 8. Okay, sub in 1 over square root 2 inside here. So I sub in each one. So easier to calculate. Alright, no calculator. Okay, minus, sub in 0 when x equals 0. So like this. Okay, so the last step. You see, so the last step, 1 over 16 pi minus 1 over 8. Okay, let's see what happened here. Okay, square root 2 power 4 is 4. Okay, square root 2 square is 2 ma. So 2 square again 4. So 4 times 1 over 4, 1. This whole thing become 1. So 1 plus 1, 2. Okay, ln 2. Okay, what happened here? This is 0. So ln 1 is 0. So left ln 2 only. Okay, therefore your answer is 1 over 16 pi minus 1 over 8 ln 2. You actually can stop here. So you see exact form in pi and in ln. You can stop here actually. But if you think, I want to factorize, I don't want to see so many fractions. Okay, fine. You factorize 1 over 16. Then this one left pi only. And suppose this is 1 over 8 ma. So you must have 2 here because 2 times 1 over 16, then only you get 1 over 8. Or 2 ln 2. Also can. This one actually better Or if you express your answer in this way, even better But I think when you do it like this, also can accept already. Alright. See that? So this is definite integration. Alright, so we have finished all the techniques of integration in indefinite integration part. Then we continue with definite integration where you need to sub in the limit. I already show all how to do definite integration for the normal function. If you substitution, how to do it. If you by parts, how to do it. Okay, so we have complete all the techniques part already. Because the following will be how we are going to apply. Or how we are going to apply integration already. Or application of integration already. Okay, so of course homework. Alright, so today you see the homework that you have to complete is exercise 3.7. Question 1 you do J and K. Question 2 you do A, D, F. And question 4. So you have 1, 2, 3, 4, 5, 6 questions here. And in your notes, as I told you, right, there are so many past year questions in this definite individual part. All right. In indefinite, not many, but indefinite, yes. You see, start from 2017 repeat paper. Because from 2018 repeat paper to 2020 repeat paper, I have discussed. All right. So all these haven't discussed. So all together, you have 22 questions. All right. So 22 questions. You have 22 here. And plus 1, 2, 3, 4, 5, 6. So altogether, you have 28 questions to answer in this weekend. Okay, so means one day you have to do 10 questions like this. Today, Friday, you must complete 9. To complete this one first. Then plus another 3 past year question. All right, up to you. You want to choose long question, short question. Tomorrow, Saturday, do another 9 or do another 10. Then Sunday, do another 9 or do another 10. Okay, in these 3 days, you must complete all these 28 questions. Okay, then next week, next Monday, I'm going to discuss question 1 to question 11. So I want every one of you, after you have complete question 1 to question 11, please write in the proper way. Scan all your questions, not only 1 to 11, 1 to 22. Please scan all your answer. Okay, scan all your answer, 1 to 22. After you have finished, you scan all. No need to forward, no need to forward. Okay, what I'm going to do is, next Monday, I'm going to discuss question 1 to 11. So in the class, 11 of you, right? So I will point out, okay, each of you have to show the answer of one question. I just simply put pick. That's why I say I want you to scan all the answers. For example, let's say I say, okay, question 1. Okay, question 1, Yuwen. Then Yuwen, you have to immediately, because through Google Meet, right, you have to represent your question 1 answer. You show to everyone, you explain. You explain. All right, you show and explain to everyone. Okay, then like this. Then I say, okay, now question 2, who? Immediately you can show because you already scanned. So you have to stand by your answer. Okay, once I want you to present, then you can show. Then we discuss, every one of us will discuss. Then you mark yourself. Okay, you mark yourself. You prepare your own answer also. You mark yourself. See how many marks you can get. Okay, Okay, so Monday we are going to discuss question 1 to 11. Then Tuesday we are going to discuss question 12 to 22. So another 11 question means every one of you will present one question. The answer of one question. All right. So don't tell me when I point you, then you say, teacher, that question I cannot do. So in this weekend, any question that you think you cannot do, either you ask your friend, ask them how to do, not copy answer from them, or please text me. Or even we can make video call. I can discuss with you the answer. I can discuss with you. All right. So there is no excuse when I appoint you to do one question and you tell me that, teacher, I don't know. All right. Okay. So enjoy your weekend. All right. Bye. See you next week.